This lesson is just 1.6-1.7. It's mostly solving equations. It's all solving equations, right? Oh no, it's inverses also. Solving and inverses. 1.6 is solving inequalities. 1.7 was inverses. TBH, I have no idea. I think his like numbers are based off the textbook, but maybe they're not. I could be making that up. I don't know. I've never actually looked at this OER textbook that I make available to you guys, because why would I? So, when you're solving an inequality, remember that an inequality means, or an inequality, when you're solving an absolute value, remember that absolute value means the distance from 0. So, for example, if I ask you the absolute value of 6, you would say 6. If I ask you the absolute value of -8, you would say 8. Absolute value keeps positives positives and makes negatives positives. That's essentially what it does. And it does that because it is the distance from 0, and distance is always positive. So when we're solving an absolute value equation, the first thing that we want to do is isolate the absolute value. So whatever is inside here, I'm not worried about right now. I'm worried about what's on the outside. And so if you're not sure, think of this as the same as 5 minus 7x equals -51, and ask yourself, what would my first step be? So your first step would be to subtract the 5. So that's going to be what I do first. And I'm going to get -7 absolute value of 4t minus 11 equals -56. And again, if I was doing that up here, if this was 7x, I would divide both sides by -7. And so then 4t minus the absolute value of 4t minus 11 equals a positive 8. And that's good because absolute value can only ever be positive. If you get absolute value equals a negative, then your answer is DNE. Okay? You have a question? You're muted. Okay, well, at this point, to get rid of the absolute value bar,
I think she's trying to tell you you have 4t minus 11 and it's 4t minus 1.
oh, crap. Thank you.
You're welcome.
Isn't it 4t plus 1?
Oh my God.
Sorry.
Happy math night. No, it's fine. Thank you for pointing that out. So at this point, if we have the absolute value of 4t plus 1 equals 8, then that means that either 4t plus 1 can equal 8 or 4t plus 1 can equal -8. Because if I put an 8 in here, I'll get 8. If I put a -8 in here, I'll get 8. So then at this point, we split this. 4t plus 1 equals 8 or 4t plus 1 equals -8. So then I'm going to subtract the 1. 7 divided by the 4. Same thing over here now, subtract the 1. Divide by the 4. So then my two answers are -9/4 and 7/4. Remember that Moore wants you to use commas to separate them. So -9/4 and 7/4. Pull this up a little. Okay. All right, so intercepts, remember that this function notation is always y, and this is always x. So the v-intercept means I'm solving for this for the x-intercept. To find the x-intercept, I set y equal to 0. So to find the v-intercept, I'm going to say 0 equals 2 absolute value of v plus 4 minus 2. And then I'm going to solve this the same way I did the one above. So I'm going to isolate the absolute value. To isolate the absolute value, I add this 2. Nope, that's an absolute value, not a parenthesis. Then I divide both sides by the 2 in front. And then I split this because if the absolute value of v plus 4 equals 1, then either v plus 4 could equal 1 or v plus 4 could equal negative 1. Subtract the 4, and either v is negative 3, subtract the 4, negative 5. I feel like, no, okay, never mind. I was going to say, I'm not sure if they want points. So they might want negative 5, negative 3. They might want negative 5, 0, negative 3, 0. I'm not sure. Has anybody done this one yet? Oh, well, it's one of those two.
I have, but I can't remember what they wanted. I'm trying to remember, but I think it was just the answer.
Just these.
Not,
Huh.
I believe so.
Put this in and you get it wrong, try this, and if you get that wrong, then it's you. So then to find the k of v intercept, you're going to set v equal to 0. So you would say y equals to absolute value of 0 plus 4 minus 2. Now we're not solving here. Here we're just going to evaluate this side. So 0 plus 4 is 4. The absolute value of 4 is 4. 2 times 4 is 8. So then again, I'm not sure if they want 6 or they want 0, 6, but it's going to be one of those two. I feel like when it says intercepts, it usually wants points, but I honestly don't remember. Okay, so then the other solving when we're dealing with absolute value is solving using inequalities. So you do something different if you have a less than you do if you have a greater than. So if you have a less than, you turn this into a compound inequality. So a less than means you have 1, and I always remembered it because 1 is less than 2. And so with this, you make 1 inequality, and with this, you make 2 inequalities. And so here's what I mean by that. The first thing you would always do is isolate the absolute value, but this absolute value is already by itself. There's nothing in front of it, outside of it. So then in order to get rid of the absolute value bars, I turn this into one long inequality. And I take this 3 and I make it negative. And if this was less than or equal to, then these would both have the or equal to's, because it does not either one of these do. But a less than, you make one long inequality. Inequality. And we call this a compound inequality. And then to solve a compound inequality, whatever you do to isolate the variable in the middle, you do to both the left and the right. So for example, if I'm trying to get the v by itself, I would subtract 8, and I have to do that out here and out here. So then this is negative 11, and this is negative 5. And then I'm going to divide by 2, so I'm going to divide all 3 sides by 2. And so then negative 11 halves is less than v is less than negative 5 halves. They want the answer in interval notation. So as an interval, this would be negative 11 halves to negative 5 halves, where both get parentheses because neither one of these had an or equal to. So now with the greater than, you're going to split it into 2 separate inequalities. Again, just like I said over here and I said above, your first step is always to isolate the absolute value. So Here, the first thing I'm going to do is subtract that 7. Then I'm going to divide by the 8. So 8 absolute value of 6v. They're fond of the v's on this one, huh? I'm going to subtract the 7. (31 minus 7) would be 24. Oop. I made that an equals. And then divide by the 8. Oh, man. So now what you're going to do here is you're going to say that either 6v plus 5 is greater than 3, or 6v plus 5, you flip this sign and you flip this sign. So is less than negative 3. And then you solve each one of those individually. So subtract the 5. Divided by the 6. Or subtract the 5. Divide by the 6. 6, so that's 4/3. And then in interval notation, we would say that's all the numbers to the left of 4/3 and all the numbers to the right of negative 1/3. So this would be negative 4/3 to infinity, union, nope, hello, that's backwards. Negative infinity to negative 4/3, union, negative 1/3 to infinity. Sorry, I keep my fan on in here because my computer makes this little room very, very hot. Okay, so this is saying everything to the right of negative 1/3. This is saying everything to the left of negative 4/3. Keep in mind that when we're writing something in interval notation, it has to be in numerical order the way that you would see it on a number line. So if you flipped these two, it would be wrong. Okay. All right. So that was absolute value. The other piece of this lesson is inverses. So an inverse is when we have functions that are opposites or that undo one another. So you do inverse operations in your daily life every day. You get up and get dressed in the morning, and then at night you get undressed. You walk to your car, and then you walk back from the car into your house. You know, like there's a million things that you do every day that are inverse operations of one another. Anytime you do something that eventually you're going to do the opposite of or undo, we consider that an inverse. So functions have inverses as well. There are some really easy ones that we can just talk about. So a good example of inverse functions would be to say that if we have 2x, then the inverse of that would be 1/2 x. Because the opposite of multiplying something by 2 would be multiplying it by 1/2. The opposite of doubling is halving. You could also say if we had g of x equals x plus 4, well then the inverse of that would be x minus 4. Because the opposite of adding 4 to something would be subtracting 4 from that thing. So those are some quick examples of inverses. So inverse functions are just two functions that are opposites of one another, or where one would undo what the first one does. So I'm sure that in his lecture, Andy went through and explained all of the properties of inverses to you. So keep in mind that if you have a point on a function, then you have the flip of that point on the inverse. So for example, if there is a point on f of x, then its inverse has that point flipped around. So if 4, 2 is on a function, then its inverse has the point 2, 4. So if 4, 2, then this must be 2, 4. If the inverse has the point -4, -9, then the original must have -9, -4. That's just the way inverses work. Okay? Now, a note that only one-to-one functions have inverses. If a function is not one-to-one, it does not have an inverse. Now, I'm not sure. I don't remember. It's been a long time since I've watched his videos, honestly. But the 3 steps, I don't remember exactly how he explained it, but the way that I always explained it is that the 3 steps to find an inverse you change f of x to y. You swap x and y. And then you solve for y. So for example, right here, I'm going to change this to y equals 2r minus 4. Then I'm going to swap y and r, so make this r equals 2y minus 4. And then I'm going to solve for y. So I'll add the 4. I'm going to put this up here. So r plus 4 equals 2y. Divide by the 2. Y equals r plus 4 over 2. And so then this is my inverse. So if you're putting this in more, make sure that you put that numerator in parentheses, r plus 4 over 2, like that. Okay? And one of the many properties that inverse functions have, that again, I'm sure that Andy mentioned in his videos, is that 2 functions that are inverses are symmetric about the line y equals x. So that's always what it is. If 2 functions are inverses, they are symmetric about the line y equals x. This will never be anything except x. Okay. All right. So he's given us 2 functions, h of r and q of r. And the first thing that we want to do, we're going to practice our skills from last week. Remember that h of q of r, with the open circle like this, it means this. So then that means I'm going to do h of q of r is r plus 5 over 4. And so I'm going to take the r in h, and I'm going to replace it with this. So that becomes 3 times, oh, that should be a 3. R plus 5 over 3 minus 5. And then here, the 3's will cancel. And I'll have r plus 5 minus 5. And then the 5's will cancel, and I will have just an r. So we're going to do that again, only this time we're going to do q of h of r, which means we're going to do q of 3r minus 5. So then I'm going to go to q, and I'm going to replace this r with a 3r minus 5. 3r minus 5 plus 5 over 3. The plus 5 and the minus 5 will cancel. The 3's will cancel. So I got just an r in both of these. And so then that means they're inverses. If when you compose in both directions, everything cancels except your variable, then your functions are inverses. Now I'm realizing that I might have led you astray up here because this might be r. Although why they would put a y here, I don't know. So there's an outside chance that this is r, because r was the variable up here. But I feel like this would have been q of r instead of y. So try that. Because more can be incredibly picky sometimes. Okay. So, quadratics, as they're drawn, are not one-to-one. A quadratic is a parabola, right? If we remember our transformation rules, this is a parabola that has been shifted to the right 3 units. This is not one-to-one. Look at it. It would fail the horizontal line test. So that means this does not have an inverse. So what we need to do is we need to restrict it down to only the increasing part so that it does have an inverse. So if I took away everything that was decreasing, it would start right here at the vertex. So the domain on which this is one-to-one is going to be 3 to infinity. And that's always going to be whatever number is inside these parentheses with the opposite sign. So if it had been t minus 6 squared, it would have been 6 to infinity. If it would have been t plus 8 squared, it would have been negative 8 to infinity. Because this number is the x value of my vertex, we want everything to the right and we don't want anything to the left. And so then, given that restricted domain, we're going to do the same thing that we did on the other page, where we're going to make it y equals t minus 3 squared. Then we're going to swap the t and the y. Then we're going to solve for y. So we're going to take the square root of both sides. And on this side, the square root and the squared will cancel. Sorry, I forget that you guys can see me sometimes. My husband just brought me in my dinner and he like gave me something that he knows that I don't eat. So then we have the square root of 3t equals y minus 3. Now I also want to make a note that I know that at one point I mentioned that every time we're solving equations, we should be putting plus or minuses in front of square roots. Inverses are the exception to that rule because, again, we're not looking for what number when squared would give me another number. We're trying to find the inverse of a function. And if we made it plus or minus the square root of t, we would have something that was not a function. So if what you have under the variable here, under the radical here, if your radicand is a variable, don't put the plus or minus in front. And then we're going to add the 3. So then here we would do SQRT of t plus 3. Okay, same 3 steps here. Change Q of W to Y. Swap W and Y. And then solve for Y. So the first thing I'm going to do is I'm going to move this 3 over to get the square root by itself. Then I'm going to square both sides. On this side, the square root and the squared cancel. So I have W plus 3 minus 3 squared equals 6y minus 4. Now I need to figure out what W minus 3 squared is. So let's FOIL this. W minus 3 times W minus 3 is going to be W squared and then minus 3W, so minus 6W plus 9. And then I'm going to add the 4. Then I'm going to divide everything by 6. Okay. So same 3 steps here. Oh no, just kidding. We're not finding the inverse here. So here, what I want you to remember is that what I said back here was that if f of x has 4, 2, then the inverse has 2, 4. So if the inverse has 3y, then this value is my y in the original point. So here's what I mean by that. If there is a point on the inverse, -3, and then I'm gonna give it a different letter. Then the flip of that point, a -3, is a point on the original. So what I'm saying here is that if I made the v my a, the y would be my -3. So if you're given a problem like this, you would say, okay, I need to know for what value of v does y equal -3. So we would say -3 equals v plus 2 over v plus 9. I'm going to put this over 1 and cross multiply. So -3 times v plus 9 equals v plus 2. -3v minus 27. I'm going to add the 27. Subtract the v. Divide by the -4. So here's what I know. I know that on f of v, we have the point. Nope, I did that backwards. There is the point -29 over 4, -3. Well, then that means on its inverse, there is -3, -29 over 4. So then this would be that -29 over 4. So again, the shortcut here is that this is my x value on the inverse, so it's a y value on the original. So just set your function equal to this number and solve. Okay. And then last but not least, we're going to do the same thing that we did 2 questions ago, where we're going to make this y. Then we're going to swap my c's and my y's. Note that I made both of those c's y's. And then we're going to solve for y. So I'm going to do the same thing here that I did right here. And I'm going to put the c over 1 and I'm going to cross multiply. So then this is going to be c times negative 3y plus 2 equals 1 times 3y minus 5. Now, if I'm solving for y, I want to get everything that has a y on one side and everything that doesn't have a y on the other. So the first step is going to be to distribute here. Negative 3cy plus 2c equals 3y minus 5. Now again, everything that has a y together and everything that doesn't have a y together. So I'm going to move this 5 over to get it away from that 3y. And then I'm going to add this term over because it does have a y. Oh, I forgot my plus 5 right there. So this should be 2c plus 5 equals 3y plus 3cy. And now I'm trying to get the y by itself, so I'm going to GCF this y out. And then I'm going to divide both sides by this. So that my inverse is 2c plus 5 over 3c plus 3.
When we start our homework, can you like keep this page up for a minute or no?
Sure. What I was actually going to, let me stop the recording because I think we're good.